Okay, we have here another interesting integral on the board. We have the integral from 0 to pi of cosine to the 10th x, sine to the 10th x, plus cos to the 10th x dx. Okay, this is actually my third time doing this problem, and it's not even a different method than the first time I did it. It's just going to be done a little quicker. So what I want to do for my method is let's just look at a particular property of the definite integral. Okay, we have this property over here to the right, and it just tells us if we have this first condition here, where f of 2a minus x equals f of x, where f of x is going to be our integral, well, it's just going to allow us to half our upper bound and bring a 2 out front. Now, the reason this is so helpful in this case is because what we found in the previous videos, if we have an integral in this form, it's just going to be equal to pi over 4. And now this matches our integral with just n being 10. So if we can use this to reduce our bound to pi over 2, then we know we can use this value of pi over 4 and finish it off really quick. So we're just going to need to do this check that f of 2a minus x works, and then we can just jump to this reduction of the bound. And again, our 2a value is just going to be this upper bound pi. So what we really want to do is we want to find f of pi minus x. And again, this is going to be our f of x value. So if I just plug in here, we'll be looking at cosine of pi minus x to the 10th, and we'll have sine of pi minus x to the 10th, and this is going to be the same as this up here. But for each of these values here, we can use the supplementary angle formula for sine and cosine. And before I rewrite this, just look at our supplementary angle formula over here on the right. If I just take this to the 10th power on both sides, well, for this one, it's just going to become sine of the 10th x. If I do the same thing here, when we take minus cosine x to the 10th, because this is an even power, that's just going to become cosine of the 10th x. So then just plugging in our values here, in the numerator, we're going to have cosine of the 10th x. We're going to have here, this is just going to become sine of the 10th x. And then we're going to have cosine of the 10th x again. But notice this is just what we have in our integral. This is just our f of x value. So this check here works. So this is true. So now with this condition satisfied, I can just rewrite the integral. So that's going to allow me to bring a 2 out front of the integral and just half the bound, go from 2a, which is pi, to a. So for our upper bound, we'll have pi over 2 to 0, and we just need to rewrite this. But now our integral is the same as this thing for n equals 10. So what we can say is this whole thing here is going to be just pi over 4. So for our final solution, we're just going to have 2 times pi over 4 or pi over 2. So that's it. Good problem. And hopefully this is the last time I'm doing this one. So we'll stop it there. Thanks everyone for watching. Have a great day.